Every electricity generation technology has advantages and disadvantages. For example, renewable technologies such as solar and wind do not produce greenhouse gases but are not always available when needed and can require significant amounts of land. On the other hand, technologies such as coal and nuclear can produce electricity in large quantities reliably around the clock but can result in significant greenhouse gases when unabated in the case of coal or long-term waste disposal considerations in the case of nuclear. Understanding these trade-offs among generating technologies reinforces the importance of having a diverse generation technology portfolio for reducing greenhouse gas emissions while economically and reliably meeting electricity demand. When applied as part of an integrated portfolio, all generation technologies can play useful roles that capitalize on their strengths. This video explores some of the advantages and challenges of both current and emerging electricity generation technologies when comparing attributes including cost, availability and operational capabilities, and environmental considerations. It presents a comparison of technologies at a high level, followed by a more detailed explanation for the assessment of each parameter analyzed for each technology. While the assessments represent the general characteristics of the technologies evaluated, the exact details of many parameters will be unique to the site, region, and/or country in which the technology is being considered. Furthermore, the details around the costs and capabilities of emerging technologies are less certain than those of generation technologies that have been mature and commercialized for decades and reflect expectations more than demonstrated capabilities. While the information included here can help to inform the planning and stakeholder engagement processes, more detailed analyses are required for making final investment and deployment decisions. One can see in this slide about all generation means from its advantage to challenges like its construction cost and electricity production cost along capacity factor. Ramping capability is a very important factor when choosing these generations in your network. Availability of these generation along total area use intensity along direct water use intensity. Comparison shows among all these generation type about direct greenhouse gas emission along direct emission, which is very important aspect tackle global warming issues on our Earth. Another important factor is direct waste products of these generation techniques along ease of permitting. Life cycle of any generation is also an important factor when considering. As conclusion, solar PV generation overall favorable in today's scenario as it has more advantage compared to other technologies where biggest factor is construction and electricity cost, but its availability is still a big challenge. Carbon capture and storage. This is a process in which a relatively pure stream of carbon dioxide (CO2) from industrial sources is separated, treated, and transported to a long-term storage location. The aim is to reduce greenhouse gas emissions and thus mitigate climate change. Carbon capture and storage has several potential benefits that why utilities going for these emerging generation technologies. Just look at the benefits like reduction of greenhouse gas emissions, generation of additional power, creation of more fuel, enrichment of concrete, bolstering manufacturing operations, job creation. Another benefit, reduction of emissions at the source, removal of other pollutants. Now take an example of coal generation plus carbon capture and storage. Carbon dioxide (CO2) capture and sequestration (CCS) is a set of technologies that can greatly reduce CO2 emissions from new and existing coal and gas-fired power plants and large industrial sources. Coal with carbon capture and storage has several potential benefits like mitigation of climate change, economic efficiency, compatibility with existing infrastructure, financial incentives. Natural gas generation plus carbon capture and storage. Natural gas with carbon capture and storage (CCS) has several potential benefits, like mitigation of climate change with lower CO2 emissions per MWH, economic efficiency, compatibility with existing infrastructure. CCS can be retrofitted to existing power and industrial plants, potentially preventing the emission of significant amounts of CO2 over the next 50 years. Financial incentives. Another benefit, proximity of storage sites. Another key advantage of CCS from natural gas plants is the likely proximity of geological storage sites in the same or similar formations from which the natural gas is sourced. Reduction of emissions at the source. Almost 50% of the greenhouse gas emissions in the United States come directly from energy production or industry. Now come to biomass generation plus carbon capture and storage. Biomass typically comprises residues, or byproducts, of forestry and agriculture, along with organic wastes. When biomass is processed, CO2 from the exhaust emissions or from process emissions can be captured. This CO2 can then be stored in the underground CCS, where the CO2 can be used in chemical processes to produce material CCU. For small modular nuclear reactors (SMR). Small modular reactors are advanced nuclear reactors that have a power capacity of up to 300 MW per unit, which is about 1/3 of the generating capacity of traditional nuclear power reactors. For offshore wind turbine generation. Offshore wind power is the use of wind farms constructed in bodies of water, usually in the ocean, to harvest wind energy to generate electricity. For solar PV generation plus storage. Many solar energy system owners are looking at ways to connect their system to a battery so they can use that energy at night or in the event of a power outage. Simply put, a solar plus storage system is a battery system that is charged by a connected solar system, such as a photovoltaic PV one. Enhanced geothermal generation. An enhanced geothermal system (EGS) generates geothermal electricity without natural convective hydrothermal resources. Traditionally, geothermal power systems operated only where naturally occurring heat, water, and rock permeability are sufficient to allow energy extraction. Here are the advantages and challenges of various current power generation technologies in this slide. Let's take an example one by one. Coal power generation. When it comes to advantages, coal is abundant, affordable, and reliable as a source of electricity. When it comes to challenges, detrimental environmental impacts, public health risks, and contributions to climate change. Natural gas power generation. When it comes to advantages, natural gas offers a reliable supply of power, especially during natural disasters when power outages are the norm. It's an indispensable energy source for emergencies. When it comes to challenges, despite the several benefits, gas generators also have a few drawbacks. Biomass power generation. When it comes to advantages, biomass energy is a renewable source of energy that can be derived from organic materials such as plants, waste, and manure. When it comes to challenges, biomass energy also has disadvantages such as inefficiency, pollution, water use, soil health, and deforestation. Nuclear power generation. When it comes to advantages, nuclear power is a source of carbon-free electricity that can run on its full potential and provide reliable baseload power for the electric grid. When it comes to challenges, producing radioactive fission waste that is toxic and hard to dispose of, requiring high upfront costs and complex management, and posing risks of accidents and weapons proliferation. Hydropower generation. When it comes to advantages, hydropower is renewable, reliable, and adaptable. It generates nearly 800 billion kilowatt-hours of electricity each year and produces more than half of the nation's emissions-free electricity. When it comes to challenges, hydropower has challenges regarding the uncertainty of how much of sun's rays it would receive, as weather can change from time to time. Onshore wind power generation. When it comes to advantages, wind is a clean, renewable energy source and is one of the most cost-effective sources of electricity. When it comes to challenges, wind turbines can be noisy and unappealing aesthetically and can sometimes adversely impact the physical environment around them. Solar PV power generation. When it comes to advantages, solar PV is usually a cost-effective way to supply large quantities of electricity needed. It's a self-sustaining source of energy. When it comes to challenges, solar PV has challenges regarding the uncertainty of how much of sun's rays it would receive, as weather can change from time to time. Concentrating solar power generation. When it comes to advantages, one of the biggest advantages of CSP is its reliability as an energy source and predictable costs. When it comes to challenges, large-scale solar power generation requires a large area of land. Geothermal power generation. When it comes to advantages, geothermal power is a renewable, reliable, and adaptable source of energy that has a low carbon footprint and can generate electricity and heat buildings. When it comes to challenges, geothermal power also has some disadvantages, such as the potential impact on ground stability and the land sinking due to the construction of geothermal facilities. Be informed that the specific advantages and challenges can vary based on the specific technology, location, and other factors.